Magnetic fields in space offer a key to the complexities lurking within the depths of the universe. They play a critical role in understanding the interactions of stars, galaxies, and black holes. These fields arise from electromagnetic interactions and vary in intensity across various regions of the universe. The Sun is a magnetic star surrounded by a dynamic magnetic field. Its magnetic field is characterized by observable phenomena such as sunspots. These spots are regions where the magnetic field intensifies and often lead to solar storms. Solar storms, by emitting charged particles into space from the Sun, can influence Earth's magnetic field and have significant effects on technological systems on the planet's surface. Magnetic fields also play a crucial role in the formation and evolution of celestial bodies. For instance, the magnetic fields of planets interact with their surroundings, protecting their atmospheres and surfaces. Earth's magnetosphere shields us from cosmic radiation, a critical factor in the development of life on our planet. Space exploration employs various technologies to better understand the nature of magnetic fields. Spacecraft are critical tools for studying magnetic fields and observing magnetic interactions in space. Additionally, mathematical modeling and simulations aid in understanding the complex behaviors of magnetic fields. In conclusion, magnetic fields in space are an important research area that helps unravel the mysteries of the universe and opens doors to new discoveries. Advances in this field can contribute significantly to the progress of both science and technology and offer exciting new opportunities for humanity's exploration of space. Magnetic fields are a significant factor influencing the space environment around planets and moons. These fields are typically generated by the rotation and movement of liquid metallic cores found in the interiors of planets. For example, Earth's magnetic field is produced by the effect of the rotating liquid outer core. Magnetic fields protect the atmospheres of planets and deflect some of the harmful particles coming from the Sun. The reason for the loss of Mars' magnetic field is still not fully understood. However, one theory suggests that the cooling and solidification of the planet's inner core led to the loss of the magnetic field. The loss of Mars' magnetic field may have affected the evolution of the planet's climate and geological structure by subjecting its atmosphere to erosion from solar winds and cosmic rays. Jupiter boasts the strongest magnetic field in the solar system. Jupiter's magnetic field is generated by the planet's massive size and the effect of its rotating liquid hydrogen core. This immense magnetic field serves as a motivation for seeking evidence of an ocean beneath the surface of one of Jupiter's moons, Europa. Venus has a much weaker magnetic field compared to Earth's. The exact reason for Venus's magnetic field is not fully known, but may be associated with the planet's slow rotation and weak inner core. The weakness of Venus's magnetic field may contribute to the influence of solar winds and radiation from the Sun on the planet's atmosphere. The magnetic field of the Moon is quite different from that of Earth. The Moon's magnetic field is relatively weak and exhibits variability in some regions. The Moon's magnetic field likely arises from local remnants of magnetic fields as a result of its geological structure. These fields provide some level of protection against the effects of the Moon's magnetosphere and harmful particles from the Sun. In conclusion, the magnetic fields of planets and moons are an important scientific topic that demonstrates the diversity and complexity of space. These fields influence the geological and atmospheric evolution of planets, while also being crucial for understanding space weather events and planning space exploration. Future research will help us better understand the origins, evolution, and effects of these magnetic fields. Magnetic fields are complex phenomena that shape the space environment around planets. These fields are generated by the internal dynamics of planets and play a critical role in sustaining life by mitigating the effects of space weather events like solar winds. However, the magnetic field of each planet and moon varies, providing important clues to understanding the internal structure and geological evolution of these bodies. For example, Jupiter boasts one of the strongest magnetic fields in the solar system. This immense magnetic field is created by the movement of liquid hydrogen within the planet. Jupiter's magnetosphere forms a massive magnetic shield around the planet, deflecting some of the solar wind and cosmic rays. This presents an exciting opportunity for the exploration of potentially habitable regions like Jupiter's moons Europa and Ganymede. Magnetic fields are complex and important phenomena that shape the space environment around planets and moons. These fields are often generated by the movement of liquid metal in the cores of planets and play a critical role in sustaining life by shielding against harmful particles from the sun and cosmic rays. Magnetic fields also influence planetary atmospheres and geological evolution, aiding in the understanding of space weather events and the planning of space exploration. The strength of magnetic fields is typically measured in Gauss G. Earth's magnetic field is approximately 0.5 Gauss, but this value can vary near the poles. For comparison, Jupiter's magnetic field can reach up to about 20,000 Gauss, while Mars's magnetic field is only around 0.01 Gauss. These significant differences reflect the diversity of planetary interior structures and dynamics. The strength of magnetic fields depends on the density and speed of the fluid metal movements within the planet. These fluid motions usually occur in the planet's core and are fueled by the planet's rotation and thermal energy. For example, in large gas giants like Jupiter, intense fluid movements of liquid hydrogen in the core generate a massive magnetic field. However, magnetic fields are not always stable. As Joseph G. O'Rourke points out, if the fluid movements in the core cease or slow down, the magnetic field can weaken or disappear entirely. This reduces the ability of planets to protect their atmospheres and surfaces from solar winds and cosmic rays, which can in turn affect the planet's climate and geology. For instance, the loss of Mars' magnetic field may have accelerated atmospheric erosion and had significant effects on the planet's temperature and surface conditions. Future research is planned to further explore the evolution and effects of magnetic fields. These studies could lead to significant advancements in planetary science and space exploration. Projects and space missions specifically focusing on the effects of planetary magnetic fields on the presence of life could provide more insights into the habitability potential of the universe. Therefore, continued research on the origin, evolution, and effects of magnetic fields is of critical importance. Yeah, just like you said, there's evidence pointing to Mars having a solid magnetic game back in the day that's backed up by stuff like finding minerals on the surface that vibe with magnetic fields and detecting traces of magnetic field action linked to Mars itself. But it's thought that this magnetic mojo eventually fizzled out, maybe even ghosted completely. So what's the deal with the other planets and moons? Well, they've all got their own magnetic styles too. In our solar system, the magnetic vibes of other planets and moons are all over the place. Take the gas giants Jupiter and Saturn, for example. They're packing some serious magnetic muscle, courtesy of some intense liquid hydrogen action going down deep inside them. On the flip side, the magnetic fields of rocky planets are a whole different ballgame. Earth's magnetic scene is powered by some slick fluid metal moves in its core. while Mars' magnetic mojo has weakened or straight up vanished over time. And then there's planets like Venus. Seems like their magnetic game is weak or even non-existent. The magnetic vibes of moons are worth mentioning too, like check out Ganymede, one of Jupiter's big-time moons. It's got its own magnetic flare going on. That could be thanks to some liquid water action deep inside the moon. All this research and evidence helps us wrap our heads around the origins, evolution, and impacts of the magnetic vibes of planets and moons. Looking ahead, with more observations, modeling, and lab work, we're set to dive even deeper into these phenomena. And that research could unlock some serious scientific goodies, touching everything from planetary science to space exploration and the evolution of life. Ice giants like Uranus and Neptune are notable planets in the solar system. Uranus has a diameter of approximately 14,500 kilometers, while Neptune's diameter is about 49,500 kilometers. The magnetic fields of these two planets are also quite substantial. Uranus's magnetic field is roughly 50 times stronger than Earth's magnetic field, while Neptune's magnetic field is about 27 times stronger than Earth's. The strength of magnetic fields is measured in Gauss G. Earth's magnetic field is approximately 0.5 Gauss. Uranus's magnetic field is around 0.23 Gauss, and Neptune's magnetic field is approximately 1.15 Gauss. This indicates that Uranus's magnetic field is weaker than Earth's, but Neptune's magnetic field is stronger than Earth's. Unlike the magnetic fields of other planets in the solar system, Uranus and Neptune's magnetic fields are inclined at an angle. This tells a more complex story about the formation and evolution of magnetic fields. Uranus's magnetic field is not aligned with the planet's axis of rotation, which is considered a key factor in the formation process of the planet's magnetic field. The magnetic fields of Uranus and Neptune act as a shield against charged particles from the sun and solar wind. These magnetic fields can also influence the atmospheres and geological evolution of the planets. Therefore, the formation and evolution of Uranus and Neptune's magnetic fields could have significant effects on the habitability potential of these planets. In the future, further research is expected to be conducted on the magnetic fields of Uranus and Neptune. This research could help us better understand the nature of these mysterious ice giants and gain a deeper understanding of the overall evolution of the solar system. Magnetic fields are one of the universe's unseen yet impactful forces. They envelop planets and stars, performing a complex dance in the depths of space. Scientists and researchers are striving to understand the origins, evolution, and effects of magnetic fields. This endeavor yields significant results in various fields, from protecting planetary atmospheres to ensuring the safety of spacecraft. The mystery of magnetic fields stems from the complexity of the fluids and movements within the inner structures of planets. For example, Earth's magnetic field arises from the rotational motion of the liquid iron-nickel alloy in its core. However, the magnetic fields of other planets may form through different processes. Ice giants like Uranus and Neptune may have unique magnetic fields influenced by the dense ice and liquids within their interiors. Future research will help us better understand the nature of magnetic fields and may even lead to new discoveries. Particularly, studying the magnetic fields of planets and stars beyond the solar system could play a crucial role in unraveling the magnetic mysteries of the universe. Such research could not only enhance the safety of space travel, but also help us better understand interplanetary interactions and the overall evolution of the universe. Let's continue this exciting journey with the tools that science provides us. By unraveling the mysteries of magnetic fields, let's take a step closer to examining the secrets of the universe. Guided by the light of science, let's embark on a journey of discovery and learning, tracing the magnetic dance of the cosmos towards new horizons. Thank you for spending this time with us in the infinity of space. By watching this video, we embarked on a journey into the depths of space and shared fascinating information about many scientific discoveries. However, there is still much more to learn about the boundlessness of space, and it seems like this journey will never truly end. By subscribing to our channel, you can receive the latest news and updates about space mysteries and scientific discoveries. In our future videos, you can expect more in-depth analysis, exciting discoveries, and captivating views of space. Each new video will provide you with an opportunity to delve even deeper into the secrets of the universe. We eagerly look forward to exploring space with you, and until the next video, stay safe and curious on your journeys among the stars. There is infinite potential in the sky, and we are delighted to accompany you on this exploration journey. Keep exploring the universe, always